Go to loop DT system. What is called loop DT system? Loop DT system, normally there is a local up here. Okay, there's a local up here. Here is your appliance. Okay, here is a local up. So this is TT system. I show you the TN system. TN system, normally the local earth, there is no local earth. Normally the earth and neutral share the same line. This is called TN system. Okay, very easy to differentiate. Okay, TT systems. Okay, this formula must respected. This formula you all must remember. Later I will show you in my demonstrations why this formula is very important. Must be respected. In order to see your impedance is enough or your impedance is overvalued for the circuit design or not. Okay, so this you all remember RA times IA must be lower or equal to 50 volt. This formula must remember. Okay, so this formula is also V equal to I times R. V equal to I times R. Okay, what is RA value? RA is the sum of resistance in ohm of the local earth system and the protective conductor for the exposed conductive part. So means to say this is the loop. This is the local earth. So this is a loop. From PE go to live, then come. Okay, sorry. Come back. This is the loop. It's a loop. So we test this loop whether the impedance or the resistance is safety for this circuit or not. Okay, so 50 is the maximum safety touch voltage. Okay, maximum safety touch voltage. It can be 25 volt in particular case like construction site and agriculture premise. Okay, for your information, generally we set this 50 volt. We set the safety touch voltage to our instrument in 50 volt in general condition for every building, except for the construction site and agriculture premise. Okay, both of these construction sites, normally they are more moisture. They are more wet water. And then this wet water may cause dangerous to the electrical, and then the construction site, there is more toolings, more electric tools are used. So there is a more possibility for the electric shock or this to happen. Okay, so they may need a safety. They may need a safety touch voltage, lower safety touch voltage. I show you here. So and they may need the lower impedance range. So this is 25 volt. So So I proceed to the IA. IA is the current causing the automatic disconnection of a protective device within a maximum disconnecting time required by IEC standard for electrical installation 230 or 3-phase, single phase or 3-phase. The tripping currents must be lower than this in this condition. In this higher of in this seconds, 1 second for the distribution circuit and circuit above, circuit of this final circuit up to for socket and the fixed connector. If the current is more than 63 amp and more than 32 amps, it may need 1 second, maximum 1 second to trip. Okay, understand? So RA is the resistance. 50 is the safety touch voltage. IA is the tripping current of your protective device. Okay. Then this formula must respected. Okay. Generally in TT system, RCD shall be used as a protective device, and in this case, IA is rated as residual operating current. So meaning to say, this formula, the IA is equal to your operating current, your RCD rated current. Okay, For instance, in a TT system protected by RCD, the maximum RA value are as this table. Okay. For example, your RCD is 30 milliamp. 30 milliamp. Okay. Your RCD is 30 milliamp rated current. Okay. The safety task voltage you set to 50 volt in general, as I explained to you just now. Then the resistance or impedance here, the maximum resistance or impedance is 1667. If higher than this value, the impedance measure if higher than this value, your RCD may not trip. If lower than this value, your RCD can trip. So can protect you from the electric fault or short circuit. Okay. Okay. So just now I explained this. This formula must be respected. If your instruments measure the RA value is 12.74 ohm. Okay. Hence, this one is R times I. R times I equal to voltage is equal to this formula. Okay. Voltage equal to I times R. So we need to say 12.74 times your IA, just now here mentioned this condition. IA is equal to your rating current of your RCD. Okay. So if your rating current is 30 milliamp, so 30 milliamp is equal to 0.03 amps. Okay. The voltage result is 0.38 volt, which is below than 50 volts. So this formula is respected. Okay, this formula is respected, meaning to say your loop is safe. Your loop design is safe. Okay. Now we go to TN system. Okay. TN system, there is a formula to be respected also. So this is the formula. ZS times current, R times I equal to voltage. Okay. What is ZS? ZS is fault loop impedance in ohm. Okay. UO is a nominal voltage between phase to earth. Phase to earth. Okay. Typically 200 VAC for both single phase and three phase circuit. Okay. So this UO is, we set it to 230 volt. Understand? And the IA is a tripping current. Tripping current of your protective device. In this condition, to meet the safety requirements, they must trip before or equal lower than this millisecond, 400 milliseconds for the circuit up to 63 amp socket up to 32 amp fixed connected load, or 5 seconds for the circuit and circuit above. Circuit this socket and fixed connected, if above 63 amps or 32 amps, is 5 seconds. Okay, this is a standard must follow. If you test is out of this standard, so the tripping currents, the tripping times is above than this. So you must change your impedance of your circuit design already. Okay. So this is the loop TN. This is a table. Okay, this is the ZS value. Here the resistance here is a ZS value. This value, sorry, ZS value. ZS value, maximum ZS value. Okay, so here, very easy. Here, protection device. Here is protection device GS or MCB. MCB got BCDK pipe. Okay, this connection time, there is a 0.4 seconds. Yeah, this one you all know. Okay. Then the rating current of the protective device. Every protective device there is a rating current. Okay, 6 amp to 100 amp. Okay. Here is the impedance. Here, this is the impedance. It's a ZS value. So it's a maximum ZS value. So for example, I pick one example for you. Okay. Just now I said ZS times IA must lower or equal to UO. This formula must be respected. It's using V equal to I times R. V equal to I times R. Okay. So for this example, I choose MCB 16M characteristic C at 230 volt. Just now I said UO must be 230 volt. Okay. No matter it's single phase or three phase, must be 230 volt. Okay. MCB 16M characteristic C. Based on this table, MCB 13 amps or 16 amps, MCB C 0.4 seconds. The impedance is 1.44. The maximum impedance respected for this formula is 1.44 ohm. Okay, so here I can calculate for you. 230 volt divided by impedance equal to 160 amp. So this is the tripping current. So this 230 volt divided by resistance equal to currents equal to this formula. Okay. So this is the tripping current. It follows this impedance. This is the tripping current. Okay. When you go and use your instrument and test the result come out to be 1.14 ohm. 1.14 ohm is lower than 1.44. 1.14 is lower than 1.44 times the tripping current is lesser than 230 volt. So meaning to say this formula is respected. Okay. Okay, another way to say, if you measure this impedance, you use your voltage over this impedance, you will get a fault current. This fault current is when there is fault happen, then this formula actually is V over R equal to I. V over R equal to I. This formula. So just now you measure 1.14. Your instrument measure 1.14 ohms. Then 230 is fixed. Okay. Then you get 202 amps fault current. Okay. So this 202 amps is higher than the tripping current. The tripping current of the MCB you are using is higher than this MCB 16 amp. Okay. So meaning to say when there is fault happen, the maximum of 202 amp, the maximum of the fault current can go through this impedance, can go through this loop is 202 amp. So it can trick your MCB. It can trick your MCB because your MCB is just 160 amp. The tripping current is 160 amp. So understand, huh? So mean to say when you you use the instrument, go and test the result. If you set to this condition, MCB 16 amp characteristic C at 230 volt, if your test result is below 1.44 ohms, meaning to say this impedance is safe to use. Okay, understand, huh? And then I go back to the TT system. Sorry, just now I missed out something. Okay, this 166, you all remember. This 1667 is a RA value, maximum RA value. This one is just now the TT system one. So you all remember what is 1667 30 milliamp. This one later I run the test, I show you what is this value. Okay. Now we proceed further. Okay. Okay. There is another function here, phase rotation. What is phase rotation? What is the use of phase rotation? When the phase, you see the below here, when the phase sequence of the three-phase system is incorrect, the connected three-phase motor and other rotating equipment runs in the opposite direction. So meaning to say, when you test, you use our instruments 6516BT go and test, connect like this. Go and test the three phase. Then the result come out is 1, 2, 3. Okay, green color, in green color. Meaning to say the phase is correct sequence. So your motor run in correct way. Okay. if you happen to see 3, 2, 1 and it's red color, so your motor will run in reverse phase sequence. Your motor will run in reverse. Okay, what happens if the motor run in reverse? Okay, in many cases, okay, the connected three-phase motor and other rotating run in the opposite direction. If your motor run in opposite direction, in many cases, this can cause hazardous conditions that may destroy your product, damage machinery, or injure to personnel. So this test is to test whether the phase is in correct sequence, the three phase is in correct sequence or reverse sequence. It is very important testing. Okay, but in this demonstration, I will not show you this phase because I don't have three phase here. Sorry. Okay, now we go to the earth test. Why we need the earth test? Okay, you see here, this diagram. I'm not sure you all see this diagram or not. Okay, here is the live voltage come down. Okay, just now I got mentioned if the insulation is not properly, if the insulation is your insulations maybe have degraded or deteriorate. The insulation may break. Okay, the insulator may break. Then the copper of the life may touch this metal case. Okay. Now you ignore this earth. You assume this condition is without earth. Okay, and without the RCD. This RCBO is a combination of RCD and NCV. Without this protecting device, this RCBO and breaker is protecting device. And then this earth, you ignore in this condition, ignore. Now I'm talking this live wire come down. Okay, if this wire is not proper insulated, then the copper wire inside the live will touch this metal case. So, for example, 230 volt come down, meaning to say this metal case will become 230 volt potential. It will create a potential difference here. Potential difference of this metal case to the ground. Okay. So, what happens if a human being go and touch this metal case? It will get electric shock. Why it will get electric shock? Because if there is voltage, there is current flow. The current will flow through his body. Okay. So these people become a wire or become a conductor. Okay. Humans act as a conductor with a resistance 1000 ohm to 3000 ohm. Okay. Understand? This one is their research or their research result. Okay. So when the current pass through, when there is a fault current, okay, there is fault current, the current pass through the human, then this human will get electric shock. If without the earth and without the RCD, the circuit is still connected, so this person will die. Okay, so understand? If there is a earth to this metal case. Okay, the earth resistance. Okay, I explain to you this formula. Okay, maybe this formula. R equal to, just now I mentioned R equal to V over I. Okay, resistance of the earth must be low enough. Okay, to let bigger current or higher current to pass through to the ground. Okay, so if you connect. So the importance of the earthing is to allow the current pass through the earth. Okay, so now the earth is happen here. Earth, you connect the earth. The earth resistance is lower than this 1000, 3000 ohm. Okay, so majority of the currents, bigger current, will pass through the earth rather than go through people. Okay. So this is the importance of the earth. Understand? Understand? You understand? Okay. Another, okay. Then we have designed our circuit with a breaker or RCD. Okay. Then these currents pass through the earth, it will divide. These currents will divide. The majority of the current will pass through the earth. Some of the currents may still pass through to the people. Okay, but it's very small current only. But cannot take too long for this current to pass through these people. Okay, because these people may die within some seconds. Okay. So that's why we come up with the RCD. RCD, it measure the current difference, it will treat, then protect this circuit, protect these people from electric shock. So the earthing is very important. Okay, understand? Huh? So another function of the earthing is when there is lightning, okay, the current, there is a high voltage and the high current will flow through to your building. Okay, so this current will straight away go to the ground. So will straight away flow to the ground. So this is the use of earth. So to test the earth is very important. So mean to say your earth must be low enough for and follow the standard. There is a standard to follow. Okay, low enough for big current to pass through. So this why we need this instrument to test earth resistance. Okay, understand? Huh? Okay. Now I think I explained all of this already. Okay. Now we go to the demonstration. Uh, okay.